how you doing today? I'm Hugo from TechCornerTV, and today I'm pumped up to show you what our friends at FNIRSI sent for review. And here I have the 2022 brand new DSO-138 PRO, the battery and battery-less versions. This is the first collaboration from FNIRSI with the channel, and I appreciate FNIRSI for sending those mini oscilloscope units, and especially because the second one can be yours, and I will give it pretty soon to a subscriber on a channel giveaway to commemorate the channel first year anniversary. All made possible by FNIRSI, so thank you. I will not waste any more time. Let me show you the features and explain everything about these oscilloscopes. Okay, so let's do this. Okay, if you know my channel, you know the first thing I do is to see what's come in the package. I already unpacked this on the mailbag channel. So let's open this second unit. Let me just open like this. It comes in this styrofoam package. Yeah, it's well packed. Let's see what we have inside. They have this welcome card. Yeah, a letter from China, FNIRSI. Okay, you have the contacts for support, direct contacts, it's always good. And inside we have a probe, a normal probe. It's the 6100. We have well packed inside this bubble bag. Let me just take this off of the way. And yeah, so we have the USB Type A to USB Type C. This is powered by a USB Type C. That is a very good new novelty. And we have a second unit. I will show you the difference between both units. This one is the one with battery. It comes with a BNC2 alligator clip probe, and inside we have also these pins, these extra pins, and I will show you why. Well, the unit is this. This is the normal FNIRSI packaging or case with this. I don't know if this is PCB, but it seems to be something like that. I have here the second unit. I will show you. And the main difference between the two. Let me take this out. The rest is all the same. The main difference between these two, as you can see, this one has a battery inside, and that is pretty cool to have the battery. The battery connects to this, I think, let me check. Yeah, connects to this socket. Yep. So let's see if we have power. Okay, so we turn the power on in here. As you can see, it has a small switch here. We have the USB port here. This is internal to be connected from the internal part, and is the socket to the battery. We have also here the reset button. Okay. We have the auto button here, the change or selection button. This is plus or add, this is the minus or minus button, and we have the OK button. So in terms of information in the screen, we have here the voltage, the amplitude. This is the vertical divisions. We have on the right of the amplitude, we have the indicator of 1 time or 10 times for the probe. Also followed by the horizontal division value. This is the time range. And DC or AC coupling. In the end, we have the run or stop mode for freezing the signal. Also, on top, we have the trigger mode. Right now it's auto. We have the falling or rising edge of the trigger. In this point, we have the frequency and the duty cycle of the PWM signal that this oscilloscope can generate. Well, these buttons have a double function, but I will show you in a bit how to use it. Okay, let's connect this to my function generator and see how it works. One thing that I see that is missing in here is the information about how much charge, the charge of the battery. It will be neat if you have some indication here in the screen what is the current charge in the battery. Okay, I will start by connecting this to my O1 XDG 2100. Right now I have a square wave on the screen with 50 kappa hertz. So yeah, it's not pretty good. But anyway, let's start by showing you the functions in here. So this is the auto. You just press it and it's quite fast to update. And the second function of this key is the calibration function. If you press it for a few seconds, okay, it will say to disconnect this, and if you press OK, it will calibrate the device. It's pretty fast, as you can see, it's already done. And let me connect this again, and we have here our signal. So the second key that you might press for a bit is the change key or select. If you press for a bit, it will show you the save and will save all the settings in the device. You can also press for a bit the OK. If the OK is not on the amplitude selection, it will show you the information on the screen. And you can take it out again by pressing this. And if you have this blue cursor, that will go to here and press OK. It will change the value on 10 times or 1 time. This will only happen when the amplitude is selected. Okay, maybe I shouldn't start by the normal working of the device. With the change, you have the blue color that allow you to change the values. Like this, you can change the amplitude of the device. If you press it again, you can change the time range. Okay, it's in here and you can see changing it. And right now you can use DC or AC. It seems not to do anything special. And if you go again, you have also run or stop. Right now we are in the trigger selection. You can use normal, single, it's triggered, and auto. Press again, it's in auto. Pressing change again, you can change the rising edge or falling edge of the trigger. And in here you can change the duty cycle of the PWM and also the frequency. It's these two values. And that's it. It's pretty simple to use. You can also take the cursor to this line to change the trigger line, the position of the trigger line, as you can see. Right now I'm taking out of the trigger values, voltage, and you can also use it in this side, but right now to change the offset. As you can see, you can change the offset of the line. So this is pretty simple to use. To be honest, it is very basic. Okay, you have the auto. Let me just do here some tests with bandwidth. Right now we have a square wave of 50 kappa hertz. Let's put one of 1 kappa hertz. Auto. Okay, the auto seems to work pretty well. Yeah, pretty satisfied with auto. Let's put now 100 kilohertz bandwidth. Auto. Okay, after 50 kilohertz we can see that the square wave it has some deformation. Let's take this to 200 kilohertz. It's the maximum of the device. Let's change the time base. Yeah, even in the the maximum time range, it's pretty hard to see something here. So I will not recommend using something over 50 kilohertz on this. But let's change this to a square sine wave. Let's see how the sine wave goes. Well, this is a little bit boring, but yeah. Okay, if you reduce the voltage, it will be better. Let's put this in 100 kappa hertz. Don't forget the maximum of this is 200 kappa hertz. So 100 kappa hertz, this is the appearance of the sine wave. Yeah. And let's do this. Okay, okay, I'm changing I forgot. Changing, okay, and let's we have the information in here. Let's do a run, and I want to, it will not go any further. Okay, let's increase the time range. Okay, 2 volts. So 10 kilohertz. Right now we have a 10 kilohertz sine wave. It's doing auto. Yeah, in 10 kilohertz you can even get a little more resolution. Even so, this is on the range of this kind of oscilloscope. This is the DSO-150. For a small oscilloscope, it's still one of my favorites. Let me just connect it here. As you can see, the difference, basically, you have in this one, this knob, that it will not appear in here. This is still one of my favorite oscilloscopes for small ones. It has a nice shell, a nice case, and yeah, you can select the values, the vertical division and the horizontal division here with the select, also the trigger. We have different separators. We even have a menu, I think. Not in this one, in the next one we have a menu. It's the DSO Pro. And yeah, but this one, it's a pretty good model. I like it very much. Comparing to this, you have a little less features in here, but this is a very much more compact version of the DSO-138. If you know the oscilloscope, you have the battery is awesome, and you have also the PWM, and I will show you the PWM working. Okay, since the PWM, I don't know if you saw this when I opened the package. They sent 4 pins to connect here. You have in this position, I will open this in a moment, but if you can see here, you have in this position output for the PWM. In the back, you have here some information. Well, you have the BNC, the reset, the USB, and the on-off in this side. As on this side, you have here 2 pins for the PWM output with the ground, and also the ground clock SWD and 3 volts. I am not sure, but I think this is not on the documentation, neither this is. But I think this is to connect to something like USB or something like that. One thing that is very interesting in this unit is the fact that you can upgrade the firmware. You just connect this to a PC, it creates a drive in the PC, Windows 10 operating system, and you just need to copy there the new firmware, and I think it will be okay. It's documented on the manual, user manual, but I don't have a firmware to experiment and to show you. So yeah, as I was telling you, in here we have the PWM output. I will do some hacking, but to test and to show you the PWM working, I'm gonna do something like this and to see if I can get it to work okay. Okay, just one more. These alligator clips are pretty messy. Not connected yet. Okay, we have a signal. Let's do the auto, and here it is. This signal is powered by the PWM on the oscilloscope. So it has a functions generator for square waves, which is pretty cool, and you can even control the signal in here. Okay, let's change the duty cycle. We are increasing the duty cycle. It's changing the voltage. I don't know why. Yeah, the VPP is... no, it's the same. But offset is changing. Okay, and we can change also the frequency. So one more select, and right now we can change the frequency of the signal, as you can see. Yep, this is the maximum. Yeah, pretty cool. Pretty simple. Let's open this and see what's inside of this device. Okay, here it is. Let's start by unconnecting the battery. The battery is 1000 milliamps hour, 3.7 voltage. They say that it lasts when fully charged 4 hours of use. We have here the screen. Seems pretty nice. Okay. I cannot take this out. It seems to start breaking, so I will not force it. In this side, we have here, in here, this is 74AC 4051. It's a 8-channel analog multiplexer, demultiplexer. On the side, this one is a general purpose GFET quad operational amplifier. Well, this is the main unit, the processor. It's a CH32F103C8 T6. It's from a Chinese manufacturer. I don't even get the datasheet in English. And this is an ARM processor. And we have here the TP5400. This is a battery charging battery manager. And well, all the rest is pretty straightforward. I think this is a octocoupler. It's the Y214S from Cosmo. But yeah, this is pretty simple. And what I want to show you is that we can solder here, even if in the back it's a little bit complicated to get in here to apply some solder. But I don't know, I don't want to force the screen out. It seems to be glued or something like that. And yeah, I will leave it for now. If you want to solder here something, you know that you have to take the screen out. So this is the board. It seems very well organized. And yeah, this is it's from the end of the last year. The product arrived this month to the market. So yeah, pretty cool. Let me assemble. Let me connect here the charger. When charging, you have here a light, a red light that shows you that is charging. But in the device you don't have any information that is charging. But with the light it seems okay. Okay, now it's that time of the video that I tell you what I think about this product. First, let me tell you, I will give this to a subscriber. So stay tuned, because in a joint giveaway from TechCorner and FNIRSI, I will give this to a lucky subscriber that might win, and I will pay the delivery costs of this device. So it's totally free. Regarding the device itself, it's a nice improvement from the original DSO-138. The form factor, this compact form factor, really works. You have a nice image, a very nice image in this device. It's very fast to do the auto function and to calibrate. It responds really fast. I think it's because of the ARM processor that I showed you before. Yeah, the form factor, this case or this shell is open, but doesn't bother me. They have several products in this form and it seems to work. And it has battery. Well, not this model, but you can, even in this model, you can buy later if you feel the need, a battery. It's a standard 3.6 volts battery and connect to the socket. So pretty easy to upgrade if you need to. And with battery, it's awesome. I love the fact you can have a battery in this. It helps a lot. You have a PWM, a signal generator, a square wave signal generator. Overall, I think it's a good product, to be honest. If you are starting in electronics, this probably will do. So, if you found any information that was useful in this video, don't forget, please give a thumbs up and subscribe if you haven't already. And if you do, don't forget, hit that bell so you can be the first one to be notified whenever I post a new video. I would like to thank to FNIRSI again for sending these two oscilloscopes, and I hope to see you in my next video. Stay safe. Cheers.